Okay, you guys, so here's a little bit of a recap of hypothesis testing. When we talk about hypothesis testing for proportions, right, this one's the only one that I will let you do by hand. So only one by hand. Okay, everything else is going to be due on StackCrunch, but this is the one that I will test you on, and you have to do this one by hand, right? And it's only with proportions. Okay, I did a little bit of the steps that I talked about in class, right? The first thing that you want to go ahead and do is state your null and alternative hypothesis, right? Then after that, you want to draw the graph, right? And the region, right? The region when we draw our normal curve, right, will depend on whatever the alternative is, right? So if it's greater than, it's going to look like this, right? If it's less than, then it's going to go now on the left-hand side. And if it's not equal to, then it's going to be on both sides, right? So if you have like P is greater than 0.5, it'll be on this side. If you have like P is less than 0.5, the P value will be here. If you have P is not equal to 0.5, then it'll be on both sides, okay? So you'll have two P values. Okay, so that will depend on the alternative, right? And make sure that you find the mean and the standard error, right? Right? And I wrote down right here what the mean is and what the standard error is. So make sure that you have this in your cheat sheet, right? Because those are going to be there. Step number 3, right? What you want to do is find the p-value based on the sample that I give you by using normal CDF. Okay, so let's go ahead and do a problem. That way you guys can kind of recap a little bit of what we did. So let me go ahead and move over here, right? So here's my problem. My problem says that it is believed that 43% of San Diegans go to the gym, right? So that's what we believe in the very beginning, okay? So we are going to obtain a random sample of 97, and 40% of this sample, so 40% of the 97, stated that they went to the gym. So as you can tell, 40 is a little bit much as smaller than 43, right? So it could either decrease or I don't know. So test the claim that the true proportion of San Diegans that go to the gym has changed. Okay, so let's go ahead and do this problem. Okay, so there's a couple things to note here. I would go ahead and look at keywords, right? The first thing that I notice is that we're talking about proportions, right? So we know that we're going to be doing what I had earlier, right? That thing, right? So we're going to follow these steps. So the first thing that I want to go ahead and do, because we're going to do a test, right? We're going to test the claim, right? So we're going to first set up my null, and I'm going to set up what my alternative is, right? So what I've noticed is that a lot of you guys are not writing the parameter. Remember, it's proportion, right? So make sure that you write the P. Right? So P is going to go there. Now, notice that we have two proportions. We have this one, the 43%. This is what we believe in the very beginning, right? And we also have this 40%, right? This 40% that comes from our sample, right? Well, this P is in our sample, right? This P is original population. So whenever you see the word, it is believed or it is claimed or anything like that, that is what's going to be our P. So this thing is my P, right? This lets me know that my P is coming up. So this is not going to be my P. Okay, so it is believed that in the beginning, it is 0.43, right? So this is what we think in the very beginning. Make sure that you write it as a decimal, right? And remember that it's always going to be equal to, right? So then in the end, well, what is this one going to be? It's either going to be a greater than, a less than, or a not equal to. So it's going to be one of the three, right? So we got to look at the keywords. So it says, test the claim that the true proportion of San Diegans that go to the gym has changed, right? Notice that this is such a vague word, right? There's no clear indication that it's greater than or less than. So we're going to go with not equal to, okay? 0.43. Okay, so we already know that this is going to be a two-sided test. So when we go to step number 2, right, and we draw our graph, we know that our normal curve is going to have two different sides, right? It's going to have one p-value over here and another p-value over here. So you have one p-value and another p-value, okay? All right, so now if we go back to number 2, we drew the graph, right? Now our regions are going to depend on the alternative, which we already know is not equal to, so it's going to be on both sides. We're going to find the mean and the standard error, right? So that's the next step. So the next step, finding the mean. So the mean is really easy, right? What is P, right? This is what we say the mean is, right? The mean. And the mean in this case, well, we have it right here, is just 0.43. So that means 0.43 is directly right in the middle. Okay, now what is going to be my standard error, right? My standard error is going to be the square root of 0.43, 1 minus 0.43 over the total, right? And the total in this case that I sampled was 97, right? So I'm going to go ahead and put 97 right here. And I'm going to put this in my calculator, right? So I don't have my calculator here with me, but I have it in my hands. Let me go ahead and put it really quickly. What I end up getting approximately is 0.05. That's what I got. Okay, that's my standard error. Okay, so this you don't have to graph. This is just something that we're going to put in the calculator. Okay, all right. Now, number what do we want to do now? Number 3, right? Find the p-value. That's our next step. So number 3, we are going to go ahead and find the p-value. Okay, so I'm going to go to number 3. I put number 3 here. Now we're going to go ahead and find the p-value. Now, let's look at this graph. So this graph looks like this. So here's 0.43, right? Here is my first p-value, and here is my other p-value, right? So how am I going to find my p-value? Well, I'm going to find it using my sample, right? There's one thing that I haven't used. I haven't used this 40%. This 40% comes from our sample, right? So 40% as a decimal is 0.4. Well, if 0.43 is right here, then 0.4 should be down here, right? Do we need to figure out what this is? Well, we can just add, we know that this is going to be 0.46, but we don't really need to figure it out, right? What we need to figure out is first, if I know that this is 0.4, let's figure out what this p-value is. So what is this p-value? Okay, so how are we going to find the first p-value, right? So I'm going to find p-value, not to be confused with this original p. This p-value is going to be using normal CDF, right? So we're going to use normal CDF. Remember, our lower bound, in this case, this goes down to negative infinity. So we're going to have negative 1 million, negative infinity, all the way to my upper bound, 0.4. So this is my upper bound. My mean, which I calculated, was 0.43. And my standard error is 0.05. Okay. So I'm going to go ahead and put that in my calculator, put normal CDF. The mean is 0.43. My sigma is 0.05. My lower bound is going to stay the same, negative 1 million. My upper bound is going to be 0.4. Okay. And what I'm going to end up getting, I get 0.27. That's what I ended up getting. So this is my p-value, but I'm not done. If this was a one-sided test, right, if it was just this one that I wanted, then I would be done. This would be the end in p-value. But notice that we also have another p-value. We have 2 p-values here, right? Well, because of symmetry, if this part is 0.27, that means this part is also 0.27. So we have 2 of them. So we're going to add them together, right? So 0.27 plus 0.27, 0.27 plus 0.27 is going to be 0.54, right? That's what we're going to get. Okay, so this is my p-value. Okay, you could have also multiplied it by 2. You could have done 0.27 times 2 and you get 0.54, right? So this only works only if you have a two-tailed test. So if you have a not equal to, right, this is when you have to multiply it by 2. Okay, so now, because if we only had one p-value, then we would use normal CDF and then we would be done. Okay, so this is my p-value. Okay, so is the p-value low? Well, let's see. Well, we have to look at our level alpha, right? If we look at alpha is 10%, right? As a decimal, that's just 0.1. Notice that the p-value is much larger than this. P-value is not low, so we cannot reject this. Cannot reject it. So we fail to reject. So because we cannot, so remember, this said we cannot reject, right? So that means that this is true, that the proportion hasn't changed. Proportion Has not changed. So we don't have enough evidence to say that it's changed. So has not changed. Okay, so hopefully this helps a little bit. And yes, it is a process, especially towards the end, and it's a lot to take in, but just practice and practice this. Okay.